This is Twit.
Bandwidth for Know-How is brought to you by CacheFly.
Today on Know-How,
Arduino 102.
Welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Balliser.
And I'm Brian Burnett.
And for the next however many minutes it takes, we're zipping open your brain and dropping in a bunch of Arduino stuff because that's how we do it.
Right? So I hope you're ready for that. Knowledge bomb.
We should mention that Brian is incredibly sleep deprived, and I am sleep deprived and very, very high on allergy medication at the moment.
Yes, which is not normally the case for you, but for me, that's pretty average.
Okay, so Brian, here's the thing. When you have a show that needs you to be up at like 7 o'clock, it's not a good idea to stay up till 4.
Right.
I'm just going to throw that out there.
Yeah, okay. Well, you know, fortunately for me, I live in Petaluma, so it's a lot easier for me to get over the studio. But because my sleep brain knows that, I set my alarm for 8 o'clock, and I get out of bed at 8:50, and I have to be here at 9.
Yeah. Well, have you ever had that moment where, like, you wake up right before your alarm?
Yes.
And you're like, oh, man, I have time.
Yeah,
so you go back to bed, and then you lose your job? I did that. Yeah.
Then you start working at Twit until you lose that job.
Okay, folks, we're not here to talk about our sleep-deprived brains. We're here to drop some Arduino knowledge on you. Now, last year, about in October or so, we did an Arduino 101 series where we took people through some of the very, very basics. What is an Arduino? How does the sketch environment work? How do you get things into and out of an Arduino?
Right. We
have done several Arduino projects since then that has required a bit more information, but one of the things that we keep getting is people want to know how we got from that basic input-output to doing things like the Arduino.
Right.
And so what we wanted to do was to give people a really short but quick series of episodes where we could break down some of the more useful bits of not advanced but intermediate Arduino knowledge.
Right, because we have started where it's basically just an LED on an Arduino. And then we've talked about breadboards, and now we're starting to integrate what looks to me like resistors, and we got some wires, we've got a whole bunch of components here on the table.
We have a plethora of things.
We've got things we're adding modular ability. Is that a word? Making it modular here.
We're going to be playing with things like a real-time clock. We're going to be going deeper into I2C devices, which is a really good way to connect a bunch of different things to your Arduino without an incredible amount of wiring. We're also going to look at things like, for example, using the onboard memory of the Arduino. Most people don't realize this, but you don't have to lose everything every time you turn off an Arduino. You just have to know how to write to the integrated memory, and that's what we're going to be taking you through over the next 3 weeks.
Very cool. And then we're leading up to like being able to do screens, have little digital screens and button integration. And I mean, ultimately, I know what project you're going for, or is that a secret?
No, go ahead. Yeah, we're going to tease it.
Okay, because you're making your own hydroponic system with that. We've talked about the Aquavase. That was like one of our started out basic Arduino projects, but you wanted to add a screen to it and make it its own self-sustaining system, which you showed me some of the code for that. And
it gets kind of crazy.
It gets a little crazy. And the thing is, when you're developing something that needs to be left alone for time, you don't want it to, you know, have an error.
The tolerance for a memory leak is a lot less when it might be running for months on time without any user intervention. Also, what I wanted to start developing a project, a platform where I could sort of take all of the logic and the screen and the expensive pieces and pull it out of, say, something like an Aquavase and plug it into a hydroponics garden. I wanted something that was that flexible, the code, the hardware, the equipment that could be moved from one project to the next with very minimal interface. And that's what we're going to be designing. But in order to get to that, we have to go through this.
Right. So we got to learn about all the little other components.
Yeah. Before we can start learning about those other components, let's do a quick primer. I'm not going to go through everything because that took an entire month. But let's take you through some of the most basic elements, a refresh of the 101, so that it's easier for you to understand what we're doing with the 102.
Okay, let's get started.
So the first thing we want to do is we have to write We always have to write to digital pins. That's one of the things that we have to do. In order for the Arduino to cause stuff to happen in the real world, you need a way to move those commands from just on the board to a relay or to an I2C device or anything that can actually take action in the real world.
Right, that makes sense. And we've covered that with like the LED projects that we've had. Like
Precisely.
Okay.
Yeah. So what we're going to do is let's go ahead and take a look at that. Alex, if you take a look at my screen here, so this is my Sketch IDE. Super, super simple. Again, you don't have to read the code off the screen, folks. We do make this code available for you. You can just download it. It has all the code examples.
But I do like your comments that you have.
Yeah, I try to comment everything.
Let's up our game a little.
Every once in a while, there's Easter eggs in the comments.
Just to make sure people are actually paying attention.
Precisely. So the first thing that you see me doing here, past the comments, is I'm defining two things. I'm defining a D pin, digital pin, 13. And I'm waiting for 50. Now that's
would you do that?
That's referring to waiting 50 milliseconds, by the way, not 50 seconds. The reason why I'm doing this is because I need to know what pin am I writing to,
right?
Which is going to be digital pin 13, and how long am I going to be waiting between my loops, and it's going to be 50 milliseconds.
Is 50 milliseconds just some arbitrary number?
Totally arbitrary.
Okay, it doesn't matter.
Completely 100% arbitrary. Now I don't have to do this here. The only reason why I'm doing it as a define is, and you will remember this from our previous projects, anytime I have something that might change from one project to the next, from one user to the next. For example, from the way I do it to the way that one of our audience members might want to do it, I want to leave it at the top because it makes it very easy to change that pin.
That's just good programming.
That's just good programming. Rather than going down through all the places in my code that might be referring to pin 13, all of those places refer to D pin, and that D pin is automatically set to 13. If I wanted to change it to 5, I would just change the 13 to a 5.
Right.
Right? Okay. But the reason why I'm using D pin 13 is, believe it or not, there is a built-in LED on the Arduino. It's at digital pin 13. You're going to see it. It'll be right here, right? That little green light that you see on right now?
Yeah.
That's actually digital pin 13. So I don't have to connect an LED to show this example. It's built into the board.
Oh. Yeah, I did not know that. That's cool.
Yeah. All right, so let's go ahead and go back to my code here. Pin mode. This is important. You can actually get away without doing this. The Arduino IDE will sometimes be able to figure out what you're trying to do. But anytime you're playing with pins, you always want to set what they're doing. In this particular case, I'm only using output. But I could change this to input if I was taking in anything from the outside world.
Right.
In this particular case, what I've done is I said pin mode, which is the command, and then I'm setting the pin mode. I have to give it two parameters. What pin and what is it doing?
Right, and you've got the D pin, which is defined up above as 13.
Right, and output, which means I'm going to be pushing data out through that pin, not input.
Right.
Now, again, if I wanted to, I could hard code this for 13 or
then
2.
If you ever wanted to go back and change it,
Precisely.
it'd be a pain.
It would be a pain. So in this particular case, I'm just going to say D pin. All right, so that's the only thing I'm doing in setup. The only thing in setup is opening up that pin and saying I'm going to use it for output. Now let's look at the loop. The loop here is super, super simple. The command is digital write. Digital write is built into the Arduino interface, and all it means is take that pin, whatever pin that might be, and again, I could have hard-coded it, but I used the D pin, so it's pin 13, and write high to it.
What does that mean?
High just means write the highest voltage.
Oh, okay.
The high, actually it's not even voltage, the high logic. So there's two. Digital is only input, it's only 1 or 0.
Right.
That's what digital means, right?
Right.
So in this particular case, I'm saying write a 1 to it.
Okay.
If I say write low, it's writing a 0 to it.
Okay, that makes sense.
Okay.
And if it was a quantum pin, then you would do 2.
Then it could be like 3 values at the same time, Brian.
We'll save that for Arduino 103.
And if it's Schrodinger's pin, it could be 1 and 0. You don't know until you open it.
You just have to keep the Arduino in a box.
With a vial of poison. All right, so let's continue. So I've got a digital write. I'm writing D pin, which is 13. I'm writing the 13, the high signal, which should turn on the LED. It's saying turn it on.
Right.
Okay. Then it's going to wait 100 well, normally I would say wait 1,000, but I'm waiting 50, because remember, this was defined up above.
Yeah.
And then it's going to write the same thing, digital write, the same pin, but it's going to write low.
So you're telling it to turn off and on.
turn off and on. Super complicated program. Let's go ahead and upload this. We're going to make sure we're setting it to the right port.
And it's going to be turning off and on 50 milliseconds? That's pretty quick.
Yeah. So hold on.
So it should be really blinky.
Compiling, and if it takes a while. Boop. And uploading, and done.
Oh.
Okay, so if you take a look at this, if you go to the side view, you can see that light is now flashing crazy fast, right? Now look what happens if I change that. So I'm going to change my define from 50. We're going to make it 1,000. And if I upload that, if you go back to the board, Alex, so watch that LED. There you go.
And now it's just solid.
Right. So now it's 1 second on, 1 second off.
There you go.
1 second on, 1 second off. And you do remember that
success.
It works, right? It's super simple. If you go back to the sketch, just remember that what's going to happen is the loop, whenever you see this void loop, it just means do whatever's inside this loop from that bracket to bracket over and over and over again. That's what an Arduino does. It's just going to repeat the same instructions.
Yeah, it's a microcontroller.
Right. Okay, so let's get past this.
Okay.
And talk a little bit about input. So this was the output. Let's talk about input. I want to take a button, and I want to be able to take what that button is doing and have Arduino understand it.
Because a button is an input, you're sending a signal to the Arduino, and then that's going to, the cause and effect.
Yes,
yeah,
yes.
That's going to make it do something.
Okay, so first of all, I have to set up the hardware. If you take a look at the overhead here, Alex, I've got some stuff. First of all, I'm going to need this.
It's so well organized.
Yeah, how about that? So I'm going to need a button. You may notice I've got some resistors here. These are all 10K ohm resistors.
All right. Why is that important?
The reason why this is important is some people think that you can just hook up a button to a digital pin, and when I push the digital pin, then it will trigger the Arduino, right?
Right.
Not so much, because remember, the Arduino is not looking for it's not looking for a switch press. It's looking for high and low.
Right. It's like a circuit, right?
It is a circuit. But here's the thing, if there is no current, so if there is no circuit, it's not high or it's low, it just doesn't exist.
Exactly, yeah.
Right, so what I need to do is I need a way to send either a low current or a high current.
Okay.
Okay, that's what the resistor is going to do. It's going to allow me to keep a constant circuit,
and then when you hit the button,
it shorts it, right, it goes from low current to high current.
Got it.
Okay, so let's go ahead and plug this in. Remember, the way that breadboards work, all of the pins in the vertical, they're connected to each other, except this. These are the power pins.
Right.
So I'm going to have 5 volts positive and ground through the top here.
Right, and you've got the resistors plugged into the ground.
Into the ground. Now, let's get there we go. Okay, so now my switch is on. Now let's wire this up. So what I need is I need to put power into my power rails. So these are my power rails. Actually, stay on that. There you go. So I'm going to go from ground to ground, and I'm going to go from my 5 volt to my 5 volt. Okay, now I need to wire the switch in. For the switch, I need to take my 5 volts
and then plug it into the other rail.
I'm going to plug, no, yeah, it switches right there.
Yeah.
And then I need my signal pin. And my signal pin is going to go from the rail that also has the resistor.
Oh, okay.
And in this particular case, I'm going to put it into pin number 2. All right, so let me explain what this circuit is doing. Right now, so with no press, because the resistor goes from ground to my signal pin, there actually is a circuit right now. Right. There's a circuit that is giving a very low current to digital pin 2.
And that's what the Arduino can detect.
That's what the Arduino can detect. If there was no current, it has no idea what it is. But right now it knows it's receiving a very low current.
Okay.
When I push this button, what's going to happen is it's going to short it. It's actually going to bypass that resistor, and it's going to give the full power from the 5 volt rail over into the digital pin.
And that's
high current.
That's what the Arduino will detect, and then doing whatever you want that button to do.
Precisely.
Okay.
All right, so let's go ahead and take a look at the code that's going to allow me to do this, which is this. Okay, so we got digital read. Again, I'm defining my button pin, and that's just the pin to which I'm connected. If I wanted to change the pin, I could just change this to 3, and I would just move that wire to pin 3. But
right.
I've got it on 2. I'm creating int on off. This is just sort of a holding place. I need to know whether or not it's on or off. I need to write a state into a holding cell. That's that holding cell. So
Okay.
it's going to tell me, is it high or is it low?
Right.
Okay. Now let's look at my setup. My setup is I'm going to have a serial console. And the reason why I want this is because I need a way to actually see what's happening.
So you can diagnose.
I can diagnose it. Then my pin mode. But notice the pin mode now is input rather than output.
Right.
So I'm saying pin mode, button pin 1, which was pin 2. So pin 2 is going to be an input. It's going to listen on pin 2. My loop is also very simple. On and off, so that's that holding place, remember?
Yep.
On and off is equal to the value of calling the function digital digital read, and giving digital read button pin 1, which is pin 2.
And then you have your if statement saying if it's
high,
is high, then print high.
Correct.
And that's for your serial. That's what the serial thing comes into. And then else, if it's not, print low.
Precisely.
That makes
And then
sense.
at the bottom here, all it does is it starts a new
Indents,
line.
yeah.
It starts a new line because
New line.
otherwise it would just be a bunch of values across the screen.
Right.
Okay, so I'm going to go ahead and upload this. It's going to take a while because it's the first time it's compiling. And in 3, 2. One of the biggest mistakes that people make here is, hold on. I think I just did something. One of the biggest mistakes that people make is they don't put the resistor, and if you don't put the resistor, it's not going to be able to give you that differential current, and you're going to have an issue.
Okay. Okay.
Yeah. So actually, hold on. This is why I should have tested this right beforehand. I'm not sending it to the right port.
Oh, to the right port.
There we go.
Maybe you should show that too, being sure that you send it to the right.
Yeah. So
serial
what was happening was Arduino kind of freaked out, and it didn't know it was supposed to send to port 3. COM 3. Yeah. All right. So now it's uploaded. Okay. So if you look over at here, this is our circuit, and now if I show you the serial console, which is going to be right here.
It should be giving you feedback.
So it's low. So this is actually, it's refreshing. So this is just a constant stream of low.
Yeah.
Look what happens when I press the button.
High, 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 high. So that's how we know the button's working. Nice.
Okay. And again, that's just the difference between a low current going through and a high current going through. And that's how we design those buttons. So anytime you're hooking up a button to Arduino, you need a way to send a very small amount of current and then a larger amount of current so that Arduino knows the difference.
Right. And then now that you've done that, if you went back to the programming, you could say, if Arduino detects high on this digital pin, tell the LED to blink or something.
Right. There are Arduinos. In fact, this one will do it. There's what's called internal pull-ups. There's actually resistors on the board that I can use.
Oh.
I try not to for these projects just because you might be using an Arduino that doesn't have internal pull-ups. Like, for example, those small ones that we like to use?
Yeah.
Those don't have internal pull-ups. Yeah, the nanos. They don't have them. This does. But I don't want to give people code that will work on this and not on that, because we've been telling people that it's interchangeable.
Right.
So we're designing it with the externals.
And I think from a visual standpoint, it's a little bit easier to conceptualize when you see it like this laid out.
It's sexy, right?
That is not the word I was going to use.
It's
informational.
You got to see the beauty, Brian.
The beauty in your spaghetti mess of breadboarding.
Wow. Okay. Whatever. All right. So that's our digital reading and our digital writing.
Okay.
The next thing that we're going to be doing is we're actually going to be showing you I2C. I2C is important in all of our future projects because so far we've been hardwiring either potentiometers or switches into our Arduinos. We need to be able to get more complex information both in and out of our Arduinos.
Right.
And the way that we're going to be doing that is using what's called the I2C bus.
Okay. I think we've used that for like the RTC, the real-time clock stuff that we've done. Okay, cool.
And screens. We're getting into screens. We've got to add screens to our project, and those are mostly going to be I2C.
Nice.
We're going to get to that in just a bit, but first, these messages.
Previously on Twit.
Mary Jo and I decided that we could really bring the show up a notch if she had a gong behind her.
Yeah, like that.
Tech News Today.
The founder of the private browser DuckDuckGo is here to tell us how to avoid being tracked while browsing.
DuckDuckGo is actually profitable. We've been profitable for several years. What people don't realize is even on Google, they make most of their money off the search engine itself, just based on the keyword you type in. And so it's really a myth that anyone needs to track you to make money in web search.
This Week in Google.
Is Google supposed to be a fact engine? Or is it supposed to be
Yes. It would behoove Google and everybody to understand that we all need better critical thinking skills.
Google should be the card catalog for the internet, not some librarian saying, well, you know, that's not true. Well, that is true.
But people don't think of Google that way.
Twit. It's where your brain and tech meet.
Guys can just check this box and they can defer updates for up to 4 weeks. Yeah.
I'm sorry, that slipped. That was a gong slip.
Sounded like a bomb.
That was a gong slip.
And we're back. Okay, Brian.
Yes.
Here's an issue. If I was to use my Arduino to keep time,
yes,
every time I turn it off, I would lose time, and I'd have to reset it.
And that sounds like a big, that's not what you want. That's a pain.
That's not what I want, especially if I'm going to be doing something like, oh, I don't know, a hydroponics garden, which requires accurate time. I mean, I can't have it reset to midnight every time I lose power. I need it to keep real time so that it can always stay on its schedule.
So that sounds like you're going to need a battery.
I'm going to need a battery, but specifically, I'm going to need what's called an RTC, a real-time clock. Not something based off of the internal frequency of the Arduino, but something that actually can give the Arduino the time that it really is.
Okay, because you could program it's quartz, right? That vibrates, and that's how it's able to keep time.
Precisely. It's a piezoelectric effect. So what's happening is there's a little piece of quartz that I've squeezed. I've squeezed it inside of a container. And when you squeeze quartz, it vibrates at a very specific frequency. I think it's 14 hertz, or 14 kilohertz. Now, if I know that it's vibrating 14,000 times every second, I can do some simple math there, and I can say, well, it needs to vibrate this many times for every second. If I know how many times it vibrates every second, I know every time it's vibrated that many times, that's 1 second.
Okay.
That works, but the problem is if I don't power, that goes away.
Lose it.
Unless I'm using something like this. So let's open up my little treasure trove.
Little goodie box.
Goodie box. I'm gonna pull. I got a bunch of these things. By the way, you can get these on Banggood. I have a link here. I buy them in packs of 10 because you always need RTCs. Super simple to use. This has way more pins than you actually need. I really only need 4 pins off of that. I need power, ground, so I need to give it 5 volts. I need to give it ground. And then I also need to have the SCL, which is the clock, and the SDA, which is the data. So I need a clock signal, I need a data signal, I need power.
Okay.
All right, so what I'm gonna do is I'm gonna go ahead and hook this up. If you go to the side here. So black is gonna go to ground, and white is gonna go to my VCC, that's my 5 volts. Wow, it just kind of naturally went in. What I probably should have done is only use the pins, only soldered the pins that I was actually gonna be using. SDA is gonna be white, and SCL is gonna be purple. You got that, Brian? Because I'm gonna need you.
No, I have no. Okay, so there's actually.
Why am I having issues here?
It's, like, it's just one of those days.
I just unplugged everything. That's okay. No, you know what?
Okay.
Okay.
So on the board, you have these distinctions, these acronyms.
There we go. Okay, so if you look at that, and actually if you can,
you
I've
can
got
see
black
this.
to ground, I've got white to VCC, which is my voltage, I've got gray to SDA, and I've got purple to SCL.
Okay.
Okay. On an Arduino Uno or a Nano, pin 4, analog pin 4 is SDA, analog pin 5 is SCL.
And that's all Arduinos?
No, that's all Arduino Nanos and Unos.
Oh, okay.
If you use a Mega, I think it's like 20 and 21.
So even if you got one of those knockoff Arduinos, it'll be fine. Okay.
So what I'm going to do is I'm going to go ahead and give it power. So again, I've got 5 volts going into here.
Right.
So make sure I do it the right way, like that.
So even though it's got the battery on it, you're going to give it power too?
Well, yeah, because I want it to be powered by the Arduino when it's operating.
Right.
And also, it needs the ground pin, because the ground pin is, if you do SDA and SCL without the ground pin, it doesn't actually do anything.
Okay.
So this is SCL, that goes into 5, and SDA goes into 4, like so.
Okay.
So now I should have an active connection. I should have SDA on 4, analog pin 4. I've got SCL on analog pin 5, and then I'm providing power off of the breadboard.
Right, power and ground. Got it.
Now, here's the fun thing about I2C.
Fun.
It's fun. It is fun.
Yeah.
Okay. Those 2 pins can be connected to more than one device. In fact, we are, in this episode, we're going to connect them to more than one device. Right. Because it's a bus.
We talked about this, where you can do multiple devices on the same wire because it transfers.
Because it looks at the address. So there's an address space. So I can have multiple devices sharing that line. And when the Arduino speaks, it's actually talking to a particular address device on that bus.
Okay.
You'll see it. You'll get it. All right, so let's go ahead and go to my code example. Super simple here. I need to include the wire library. And if you don't know what including a wire library means, you really do need to go back to Arduino 101. And then I'm defining this. Remember how I said that the I2C talks to a particular address on that bus? This is that address. So at 0 by 68, that's the address of my RTC.
How do you know that?
Because when I bought this, it actually told me that the address was 0 by 68.
And that's defined by the manufacturer?
Yeah.
Okay.
Yeah. All right, so now let's go to my setup. In my setup, I have wire begin. All that does is it says open up the I2C bus.
Okay.
Then I have serial begin 9600. That's opening up my serial bus.
So you can debug it.
So I can see it, correct. Pin mode, again, see, pin mode's here again. Output, because I'm going to be doing something at some point.
And you've set it to 13 instead of an...
That's the internal, remember, that's the one that has the LED on it, right?
Right.
And then I'm also doing this. Set DS time 0, 10, 14, 5, 23, 3, and 17. All that is it sets the clock. When you first get an RTC, the clock is not set. Okay, and this will allow me to set it.
Okay.
All right, so let's go ahead and upload this. Oh, did I set it for port 3? I did. Okay, so it's uploading, and...
Boom, it's up.
There we go. Oh, there we go. Done uploading. So if I open up my serial console, this is what I should see.
Day of the week.
There we go.
Thursday, yeah.
Which actually is the wrong time because I didn't set it properly. Because this, I actually didn't. But this is the information I'm getting back. And I'll show you the programming in just a bit so you understand why it's giving me this information.
Right.
But it's giving me, if you go back to that, Alex, it's giving me a time, it's giving me the date, the month, the year, and the day of the week.
Okay. And I'm guessing that's what those numbers are in the set DS32 time, yeah.
Precisely.
0, 10, 14, yeah.
Precisely. If you look at this, so look at the actual function itself. Set DS3231 time. This is the function that I called up here. And because it's in setup, it only gets called once. It gets called as the Arduino turns on. So those numbers that I gave it second, then minute, then hour, then day of week, then day of month, then year.
Okay.
It's in that order. So for example, if I wanted to, what time is it actually right now?
So it's 11:44.
Let's call it 45 because it's going to take me a while. So 45, and then the next one is going to be hour. What hour is it?
It's 11.
It's 11. And then the next one I'm going to need is day of week, which is correct. It's, everything else is set. So I'm going to upload that. And after that's uploaded, then the RTC will be set to the right information. And from now on, as long as that battery doesn't die, it will keep that time.
Okay.
You only have to do this the very first time it's done uploading. Let's open up the serial monitor. And now we're actually seeing the right time.
So if I unplug the Arduino right now, it would stop sending signal to the computer, but if I plugged it back in, it would still have that date.
It would still have that date. Right?
Okay.
Now,
that's what we want.
Here's the thing, and this is, we're going to be changing this in a bit. We only want to run this once. If I keep this line of code, Alex, if you go back, if I keep this line of code in here,
it'll reset it.
Every time I turn on the Arduino, it's going to reset it to this time. So what I'm going to do is I'm going to comment it out. If I ever need to set it again, it will just, then I'll uncomment this.
Okay.
But now I need to upload the new code because that old code, every time I turn on the Arduino, it will start from 11:45.
That makes sense. Okay.
So let's look at what else this is doing. All of this, and again, this is, you don't have to copy this, it's going to be in the show notes. All of this, these are just the functions that come with the RTC library. So this gives me a decimal to binary and binary to decimal conversions. You don't need to know how that works, just know that you need that in there.
Okay.
This is the function that sets the time on my, my real-time clock. This is the function that reads the time off my real-time clock. This is important because anytime I want to do work based on the time, I will need that function. I will need to read from the clock.
Right.
Okay. This is the function. All this does is it pushes the data out to the serial console.
Okay.
Okay. So if I don't need to push out to the serial console, I don't actually need that function in there. And then the next one is TikTok. And let me show you what TikTok does. So let's go to the loop. If you look at the actual program loop, remember what I said? This is the thing that's going to happen over and over and over again. It just keeps doing it for as long as it can, right?
Yeah.
It's only got 3 things. Display time, which pushes the time to the serial console. Tick-tock, and then it waits a second.
I don't know what tick-tock is, though.
Tick-tock is this. So I create those variables, second, minute, hour, day of week, day of month, month and year. I read, that's that function. I read into the variables I just created the information from the real-time clock.
Right.
Then I'm going to print to my serial console second, which is this. So it's the variable second, the data that it gets from the real-time clock. So what second is it? This is called a modulus, a mod.
It's the % sign there?
It's the % sign. It's not division. What this is divide the number by whatever I want.
In this case, it's 2.
And give me whatever is left over.
Oh, okay.
So if you go back to that, think about this. If I divide 1 by 2,
you get 0.5?
I get nothing. Oh. Right. In this particular case, there's not, because 2 can't go into 1.
Oh, right.
But what's left over?
0.
1.
Oh.
Right? Because I didn't take anything away, right?
Yeah,
now
exactly.
I divide 2 by 2.
Okay.
That goes in once. What's left over?
Nothing.
Nothing.
Yeah.
Okay, let's go to 3. 3 mod 2. So 3 divided by 2, it goes in 1.
But you have a remainder.
I have a remainder of 1. Now let's try 10. So
5 times.
5 times. Is there anything left over?
No.
0. So if I do mod 2, it's guaranteed I can only get 2 possible results, 0 or 1.
Okay.
Odd or even.
Okay.
Odd or even. That's it.
Odd or even.
So if it's an odd number, I get 1 left over. If it's an even number, I get none left over.
Okay.
And that's why this is called tick-tock. If you go back to my serial console, you'll see 1, 0, 1, 0,
Yeah.
1, 0.
Now, why do you want to do that?
That's just for fun. Now, if you go ahead and go to the side view, Alex, if you'll notice, see that light? Remember digital pin 13? So when it's on, when it's a tick, it turns the light on. And when it's a talk, it turns the light off.
Okay.
The only reason why we're doing this is to show you taking information from the real-time clock and actually doing something with it. In this particular case, I'm taking one little piece of information, the second.
Right.
And I'm saying, if there is anything left over, turn on the light.
Right.
In other words, if it's odd, turn on the light. If there's nothing left over, turn the light off.
Right.
So if it's even,
you could set that for not just seconds. You could do minutes. You could do hour.
Yeah, exactly. So and actually, we have a project coming up where we're designing an LED clock. And the way that we're going to be doing this is we're going to be pulling the data off the RTC, and then we do a bunch of math to it to figure out exactly what should light up.
Math is cool.
Math! Math is your friend.
Cool.
Does that make sense?
It does make sense, yeah.
Okay.
I like that.
So that shows you how we can pull off information from the RTC and do something useful with it. However, we are still bound by the serial console. So far in all the projects, from the Arduino to this, if you don't have the serial console hooked up, you can't really get anything out of it, right?
So that sounds like you want to hook up a screen to the Arduino.
That's very astute, Brian. Maybe that's what we should do next. We're going to show you how you can hook up an I2C screen so you can actually get information off the Arduino without having to have it hooked up to a computer.
I like this.
All right, so we're going to be showing you that just next. But first, these messages.
Here's a look at just a few of the stories we'll be watching in the week ahead. First, the Nintendo Switch has been on short supply, but apparently Wednesday, March 22nd is a magical date. And that GameStop will get an influx of fresh new batches of consoles, meaning you too can get in on the fun. Oh, who are we kidding? They'll sell out before you get there. On Friday, March 24th, Samsung's next big tablet, the Galaxy Tab S3, will hit store shelves and will set you back a cool $600. That gets you a premium 9.7-inch Android tablet complete with an S Pen for when you feel inspired. Finally, if you're like me, life was too busy for you and you missed Star Wars Rogue One in the theater. And who are we kidding? Because that's no damn excuse. But still, have no fear because the digital HD version will hit your screen on the 24th as well. Who knows? Maybe it'll hit the screen of your fancy new Samsung Galaxy Tab S3 that you bought because GameStop was sold out of Nintendo Switches. That's a look at a few of the things we'll be tracking in the coming week. I'm out next week on vacation, but you can join Megan Maroney and Nathan Olivares-Giles on Tech News Today every weekday at 4 p.m. Pacific, 7 p.m. Eastern here on Twit.
And we're back. Okay, Brian.
Yes.
I've got myself a beautiful little screen here. In fact, Alex, if you show them the link for this, very inexpensive. These things sell for about $6 less if you buy them in bulk. Super simple. It's 20 characters by 4 lines. So it's 4 lines high. It's 20 characters wide.
Pretty basic.
This is used the world over because it's a bright screen. It can be read in basically any environment. It's not expensive, and it communicates over I2C, so I don't need a lot of connections.
Okay, nice.
So let's go ahead and hook this up again, just like we did with the RTC. And remember, the RTC is still hooked up. It is still active. So we are now adding another device to that I2C bus.
Just rip that power cable out.
Don't be messing my stuff up. So in this particular case, I've got ground is black and my power is red. So I just do that right like this.
Black is ground, red is power. That's pretty logical.
Power. Well, you'd be surprised once you start running out of jumpers. Okay, so what it's done is you can see the LED on the screen has lit up, so that tells me that it's on.
It's receiving power.
But now I need to get this into the data bus.
Right.
And my SDA is going to be white.
Okay.
And by the way, I'm already using this. I've already got the RTC plugged in here.
Yeah.
Thankfully, there is a second set of SDA and SCL pins on the Arduino Uno, which is why I love it as a development board. It's up top. It's actually labeled. I don't know if you can see. No, you can't see that, but you can verify, Brian. See how one says SDA, one says SCL?
He's not lying, folks.
I'm not. Well,
though they are there. I see them.
Not this time.
Are there only 2 on the ports, SDA ports?
But they don't have to be plugged in here. I could actually use this. It's the same wire. It's the exact same wire. So I could like Scotch tape them together as long as I've got them plugged into SDA and SCL properly.
That's the beauty,
So the screen is now on. Let me do this. But there's nothing being displayed because I'm currently not writing anything to it.
Right.
Okay, so let's go ahead.
We're getting power to it. We know it works.
We're getting power to it and we know it works, but let's go ahead and write to it. So I need a couple of libraries here. First is wire.
Yeah.
We've already used that. Ooh. This is a new one, Liquid Crystal. This is very easy to get. Let me show you I've already got it installed on this particular computer, but if you go to Sketch, Include Library, Manage Libraries, you can just type
Liquid Crystal?
Liquid Crystal, I2C, and you have to put I2C because there is actually another one for non-I2C screens.
Oh, okay.
And right here, that one. See, Liquid Crystal I2C. It's already installed, but just click Install and it will auto-install the library into your Sketch.
Okay.
Okay, so now I've got that in there. Let me go ahead and upload this.
And the whole point of that is so that the Arduino commands talk to the screen.
Right, because I need that library because that library will allow the Arduino to tell the screen to do stuff. Now, what is the Arduino telling the screen to do? If you look at this, I'm going to do wire begin, so that opens up the I2C bus, LCD init. I'm initializing the LCD, and then LCD backlight. I'm turning the backlight on.
Oh,
so
can you turn it off?
I can turn the backlight off. So I could have, say, a sleep function. After 10 minutes, just go ahead and turn the screen off and save power.
Right, or set it for a timer, where it's like between 12 midnight until 6 in the morning, turn it off.
Look at my face. Okay, but then I'm being super simple here. If I look at the LCD test, I'm only asking it to do these 4 things. LCD set cursor. In other words, I'm saying, look at the X and the Y coordinates, go to that coordinate, and then do the next thing. And the next thing is to print. So I'm going to coordinates 0, 0, and I'm printing line 1. Then I'm going to go to coordinates 0, 1, and print line 2. Then I'm going to go to 0, 2, print line 3, go to 0, 3, which is the last line, because there's 4 lines, and print line 3.
So the first...
line 4, sorry.
The first number is the horizontal, and then the second number is the vertical.
Precisely. Now, I'm sorry to do this to you. That's not always the case. Like when we go to the OLED example, because we've got an OLED screen in the next episode, it's actually switched. It's XY. This one's YX. Just read the instructions before you start programming for it. Otherwise, you're going to end up with stuff in the wrong place. So if you go to my the side cam here, you can see it's done exactly that. Line 1, line 2, line 3, line 3. Actually, let me fix that because I just fixed it in the code.
Line 3, line 3.
This is not spectacularly useful at the moment. So it's rebooting, and then there we go. Line 1, line 2, line 3, and line 4. But it shows you how easy it is to write to the screen. All you need to know is the XY coordinates where you want the text, and just know that you only have 20 characters across and 4 characters up and down.
Cool.
All right? Okay. How about we do something a bit more useful with this?
But I like just looking at the word line on the screen.
Well, I mean, we just looked at the clock, right? We looked at a real-time clock. What if, I don't know, what if there was a way
to send the clock to the screen?
That would be awesome, right?
That would be pretty cool.
Let's go ahead and do that. I'm going to start compiling that. Looks the same. So I'm starting with the same includes, the same libraries. I'll explain why I have these variables, last hour, last minute, and last second. But let's first of all, you'll remember all of this code is from the last example we did. This is all the stuff you need for the RTC, for the real-time clock to work. But now let's go ahead and look at my loop. My loop does one thing. Remember, the loop is the thing that Arduino does over and over again. So all this is going to do is call the function home screen over and over and over and over again.
Okay.
Okay. And this is the function home screen right here. Here's what it's going to do. The first thing the home screen does is it creates variables to store all the information it's going to get from the real-time clock. Then it calls the real-time clock and it fills those variables with the second, the minute, the hour, the day of the week, the day of the month, and the year.
Okay.
Now,
the instructions for the LCD.
Yeah. I'm going to do a little math, Brian.
Uh-oh.
We've got to do some math here.
More math.
Yeah. All right. So I'm going to print to my LCD. So I'm turning on the backlight. I'm setting the cursor to 0, 0. And then I'm printing time. So it's going to say time, and then it's going to do all this stuff. I could just put print second, print minute, print hour, print day of week, print day of month, and print year. Here's the problem. If I do that, remember how many times it's the loop's just going to keep going over and over again, right?
Right.
What's going to happen is the screen's just going to be flickering like crazy because it's going to be writing, so just constantly writing.
Okay.
So what I need a way to write to the screen, but only the parts that have changed. It will reduce the amount of flicker.
Okay, that makes sense.
Okay. So, and this is how I'm going to do it. If the last hour is not equal to the hour, so this is why I created that variable up top called last hour. If the hour has not changed, do nothing.
Okay.
If the hour has changed and it's less than 10, then only change the one character that has changed.
That makes sense, yep.
If the hour has changed and everything has changed, then go ahead and rewrite the entire hour.
Okay.
And I use that same code over and over for the minute and for the second. It's the same thing. Only write the part of the screen that has actually changed.
Right.
If you want to see what this looks like, just leave this part out.
And watch it flicker.
And the reason why we're not doing it is because this could trigger an epileptic seizure. So just note, because it flickers like crazy. But with the right code, Alex, if you go to our screen here, I'm going to go ahead and upload this as soon as I set the port correctly.
And did you define what line it's printing to?
Yes, it's 0, 0 up top, and then it there. See, it shows you.
And then will it parse it down? Oh no, it just fits on the one line.
There you go. So if you look, there we go. So time is 11:59, and notice how it's only rewriting the part of the screen that's actually changed.
Right.
But notice how there's like a little delay. It's a little flicker.
Yeah.
Imagine that happening across the entire screen. That's what it would be doing if we didn't have that little bit of math in there to make sure that it only refreshes the parts that need to be refreshed.
Right. You wouldn't be able to read it.
No, it'd just be a blur of moving characters.
Okay.
Okay.
Cool.
Super, super simple. The code on this is not hard at all. Neither is the math.
Right.
But what we've done, I mean, imagine what we've done. We've taken off the I2C bus data from our real-time clock. We've processed it so that we only change the stuff that needs to be changed. And then we push it out through that same I2C bus to a monitor.
That's cool.
Okay, and it was just a couple of lines of code. Next week, Brian, I'm going to be showing them how to do this with an OLED screen. Because OLED, I mean,
those are pretty.
They're pretty and they're colorful and they use up less power. But then we're also going to have to do some other things. Like, for example, right now, if I want to, Alex, if you go here, if I want to change this time, I have to go into my code. I have to uncomment that set time. I have to be connected to the serial monitor in order to make it set to the right time.
And then upload it, and then upload it with the commented.
Right. Ultimately, what we want out of our Arduino projects is we want our Arduinos to be fully functional, standalone. And so that's what we're going to be doing next week. We're going to be showing you how to combine the buttons with our I2C devices, and maybe just a little trickery so that we can store things inside of the internal Arduino memory so it doesn't go away when we turn off the power.
I like that. Yeah. I mean, is that, wait, what's this project?
Oh, I don't know.
This little thing with buttons and stuff here?
Maybe this actually is that. But inside of this case, there actually is already the power regulator, the Arduino Nano, and the real-time clock. And maybe I'm designing this so that this is actually, it's like a cassette. So you can plug it in to your aquavase. You can plug it into your outside garden. And this controls all the functions you ever need.
That is cool. Yeah, it's like a little cartridge.
Yeah, actually, I kind of wanted to put the Nintendo cartridge at the bottom. But it was problematic.
That is really cool.
Yeah. So that's coming up on the next episode of Know How.
Nice.
Brian, this is a lot of information. We want to make sure that they can especially get all of the code.
They should just memorize it. They should just watch it and read it as we go along.
I don't know what you guys are doing.
All that code, just copy it. Like, yeah, look at that and then write it down.
Here, just wait. Alex, stay there. Okay.
Okay, scroll. Yeah, you can scroll faster than that.
Yeah. All right.
So just have a notebook out and write it down.
Yeah, what? We're
no
done,
big
right?
deal.
No, you can download that. Just download it from our show notes page. Brian, where do they find that?
They can find that at twit.tv/KH. And yeah, like Padre said, we're not using GitHub for these, are we? Because are we just using Dropbox? And we download the files?
I opened up a new folder on Dropbox. I do not like this. We're probably going to have to move it over to GitHub. Actually, the chat room had that great idea. Said, why don't we move everything, including the 3D printed files, over to GitHub? We can do that.
It's just going to take time.
It's going to take time because now we have to go back to the entire inventory of know-how shows and fix everything that Dropbox broke.
Or we can just start now. Everything from this point forward will be GitHub.
And the reason why Cranky Hippo is saying this is because when I say we have to go and fix it, what I really mean is he has to go and fix it.
Which means it may or may not happen. But anyway, if you want to find the show notes, if you want to download the code, you're going to have to go over to twit.tv/KH. And not only will you be able to find that stuff, but you can subscribe to the show and download because we're doing these multi-part episodes. So you're going to want to download them, keep track of what we're doing.
Yeah, and also don't forget that you can find us on the socials. If you've got an Arduino project that you're particularly proud of, we want to see it. We love it. I mean, it actually inspires us.
Yeah.
The whole idea of the maker movement is not just for me to make something and then it's useful. I want what we make to inspire you to make something better. We've said this before in a joking manner, but we really do mean it.
Yeah.
We are never more proud than when one of our know-it-alls takes something that we've done and makes a better version of it. So make a better version and share it with the rest of us.
Definitely.
Yeah. You're going to find that at our Google Plus group. Just go to Google Plus and look for Know-How. There's a very short join-up process so we can keep out the spam accounts. But once you're in, you get access to almost 11,000 Kitas. That's our know-it-alls. You can find projects that you want to do. You can ask questions. You can answer questions. You can be the core of Know-How.
That's right. But if you want to see what we're doing when we're not on Know-How, or maybe some future projects that we're working on behind the scenes, the place to check that out is on Twitter, and I am at cranky_hippo.
And you're going to find me at Padre SJ. And we've actually got a third member of our crew. It's very, very important. We love him to death. We make fun of him, but we really rely on him. We call him Julius. So Julius, thank you very much for all of your work all these years. You can find Julius at twitter.com/ANELF3. Just
first name Orange Julius.
Excuse me, Padre. It's pronounced Alex.
No, it's not nearly as delicious.
No, it's not.
Yes.
Until next time, I am Father Robert Ballas here.
I'm Brian Burnett.
And now that you know how,
go RTC or Arduino. I don't know what I would do for this one. I'm gonna push your buttons though. It's so clicky.